Hello, everyone. Welcome to another Ubuntu on Air session. My name is Rhys Davis. I am a developer advocate at Canonical, but today we're all about community stuff and community things, which is what we're here to talk about on Ubuntu on Air. The most astute people who are listening right now and watching right now will be able to see that Monica's not with me today because, I must have left this open in the background so that I can hear myself speaking. Let me fix that quickly. Sorry, everyone. What's going on here? That's not good. I don't know where it is. Tricky. This never happens. Okay. There we go. That should be better. Sweet. So, Monica's not here today because she's on a plane, but hopefully she'll be back next time. We'll be able to speak to this next time, and she might even join live when we're speaking. Today we'll be talking about telecommunications things, a bit of telco with a product manager at Canonical, but we'll get to that in a second. We'll introduce everyone in a moment. Right now, I'm going to just give a little bit of community news, see what's been going on just while people turn up, because we're still waiting for people. So if anyone's still interested, the Ubuntu wallpaper competition for the 2110 release will be closing tomorrow. So if you haven't submitted a submission yet, but you want to, make sure you do it now, because as of tomorrow morning, it'll be closed and the voting will begin. There'll be a nice form that'll be sent out in a blog post and on Twitter and in Discourse. So you shouldn't be able to miss it, but you have to get your votes in. You'll have 10 things to vote for, and then and that'll be it. What else has been going on? The first person to apply for Ubuntu membership using the new process has done so. They've gone ahead and they've started using the new process, even though we weren't finished with it yet, which is great because it means people are applying for membership, and that's good. There's a nice discussion going on in the Ubuntu discourse about the code of conduct, what it means and how we can embody it and how we can do more about being more inclusive and more diverse, and really start making improvements and making better decisions around the code of conduct. And next week, tomorrow, we have our first. And next week, we have our first community streamers who will be joining the channel and running their own streams without Monica and I. Although we might be in the background for the first few, but that'll be it. And that's really exciting because it means we can start opening the channel up to more community members and have more community people doing things on Ubuntu on Air, which is what it's here for in the first place anyway. So those are all the bullet points that I have. So let's talk about telco stuff. Let me introduce everybody now to. I'm going to try and say his name right. To Maciej, product manager at Canonical. Hello.
Perfect. Hello everyone. Hello Rhys. Thanks for having me here.
You're very welcome. Thank you for coming. Would you like to give a brief introduction to yourself while I tweet about this stream?
Yeah, sure. So my name is Maciej Mazur. I'm taking care of Telco for Canonical, but also part of some open source communities. Currently mainly focusing on HCOSM. I'm the VNF onboarding chair there. And don't worry about these acronyms. Telco is full of acronyms, and we'll be explaining all of them later during the discussion. But basically, about me, my background is in either telco security and AI/ML in telco. I was working for companies like Nokia, HP, doing some consulting work, but basically all the time working with telecommunication and trying to improve the way how we connect between each other.
Cool. It sounds very good and interesting, and we'll get into all of that in a second. If anyone has any questions for Maciej as we go along, ask them away in chat. We'll respond to them either toward the end, or if it's a particularly relevant question, we'll pick it up in the middle and talk about it there and then. We've had a couple of questions come in on Discourse. We'll answer those as well. But like we start every stream with a guest, I want to just first start by asking you how you got started in open source and where you started with Ubuntu.
Okay, that's two different things actually. So I started being introduced to open source software and Linux quite early. It was in the days of beginning of Slackware distribution. And my cousin, who was like a couple of years older than me, started studying biotechnology, and they were already using Linux for doing some research on synthesis of some particles. I don't even remember what that was, but basically he started showing me nice things. It was the days of 486 CPUs and 16 megabytes of RAM. Woohoo, I'm the best one in the neighborhood. And he started showing 3D molecules running around and so on. And I thought hey, that's much better than my computer. I want this. So I started getting into that and learning Linux and this kind of stuff. And after that, there was a big break in that due to my previous career choices working for the big vendors. Were always stuck into proprietary software for a while, but I started getting involved with more and more open source software in telecommunication because it was getting more and more popular. And that's how I got introduced to Ubuntu and to the community in general. In some of the events before COVID, when we were still able to meet face-to-face, I met few people working for the community and doing interesting work, and they basically got me hooked up of different technologies, and that's how I ended up here.
Nice. That's how you ended up here. So how did you? So if you were working for Telco stuff before you ended up here, before you got into the community and Ubuntu and things, where did you start with Telco? How did you get into Telco stuff?
I got into telco stuff in the beginning of my career. I was actually studying telecommunication because that's what I was interested in. I studied on the Technical University in Wrocław in Poland. And there I had a couple of nice professors who got me interested in mobile networks. And by that time it was something between 2G and 3G in terms of the network evolution. And we started playing with simulators and building our own networks, and that got me excited that actually, the stuff that was in my mind previously reserved for the big governments and building an entire country network, you can actually do it yourself. And now even more than ever with the new open source technologies that are available.
And so folks watching might have read or seen a sort of a blog post tutorial that you put out a little while ago about creating a relatively cheap localized network, right? Is that a good description, or would you expand on that a little bit?
Yeah, that's a good start of a description. So basically, what we can do right now, if you are interested in especially telco security research or doing some small tinkering and playing with some IoT devices at home, you can actually, using very simple hardware like a Raspberry Pi and Blade RF and maybe some Qualcomm modem, build for less than $1,000 a whole 5G network at your home to do even calls, texts, internet connectivity, and everything. And it's quite easy. There are a lot of good tutorials there. So yeah, it's easier than ever to start, but also that there got somehow a lot of people scared. Because all the security in telco, especially in 2G and 3G era, there was almost no security. The idea was that there is a trust between the parties, and the networks like legacy protocols like SS7 or legacy 2G over-the-air communication, it was not secured. And the idea was that, hey, it's, there are only two companies doing that, so we don't have to worry, just like with the beginnings of the internet. But later on, they figured out that it's quite popular and everyone has an iPhone or whatever kind of phone in their pocket. So basically, the whole security of older technologies relies on obscurity. Not many people know that. These are not standard, it's not TCP/IP, it's not standard internet. So not many people tinker with it. So yeah, we are quite safe because it's tough to learn. And that was the attitude. And now when everyone can build their own network and actually see how it works and inspect the packets and do some Wireshark playing and looking into that will get interesting. I expect many more vulnerabilities being discovered now because it's much easier to access and have your own network, because obviously you cannot do it on your typical Orange or T-Mobile network, and I would not encourage you to do that because it's illegal. Also about if we talk about illegal stuff, when you want to build your own private mobile network, you need to make sure what are the regulations in your country, because they vary a lot, and there is frequencies. If you want to not only receive frequencies but actually have an antenna that broadcasts something, many countries have regulations around it, and there are special licenses for the spectrum that operators buy. In countries, at least like in US, you get CBRS, a special band for citizens where you can do whatever you want, basically. In Europe, there is LTE-U, LTE unlicensed, and 5G-U, 5G unlicensed, which are working on the frequencies like 2.4 gigahertz or 5 gigahertz, like your Wi-Fi router. Like you can put a router wherever you want and it's fine. But if you start broadcasting on a frequency that is not reserved for citizen, but for the major telecom players, you may get in trouble. So watch out for that. And yeah, it depends on the country, because in some countries you can broadcast whatever you want if you don't broadcast outside of your property. But obviously not many people have 10 acres of land and can play with that. And in most of the European countries, universities get a special, basically allocation, or sort of the government is looking the other way. Basically, if you are in the dormitory or in the technical university area, people are doing that and it's okay. So really check your local regulations. That's important.
So check your local regulations. Don't do this kind of thing at home unless you've checked it. Disclaimers out of the way. Warnings out of the way. I'm going to take a step back and sort of look at a bigger picture, and then maybe we zoom in. We'll probably talk a little bit more about security and network security in a bit, and when we get into more open sourcey things and more telco things. But first, I wanted to ask how much in general now. So big picture, how much is open source software really actually used in telco? How much of it is open source versus how much of it is proprietary stuff?
So it might be surprising to people, because everyone thinks that telco is this hermetic proprietary business, but actually it's hugely relying on open source. If you look at the telco network, it has three main pieces. You get your radio network, where there is antenna on the rooftop of your building or somewhere, like a small compute there. And then there is the core network, the big data center, when all the call processing happens, where basically your data stream is connected to the internet and so on. And you get the services layer. And on all of those, the infrastructure is based on open source technology. So the core data centers these days run mostly on OpenStack. Some of the tier 1 modern operators already migrating to Kubernetes. VMware is very rare, or other proprietary solutions in that space. On the radio side, also the basic infrastructure for radio is containers based, so Kubernetes again. And if you look at the impact of other open source projects like the Open RAN, the huge movement right now in telco in general, that the radio network is opening. So basically anyone now can create a piece of the radio network and with standardized interfaces plug it into others. So you can have proprietary Nokia bit with two open source bits, and it will all work nicely together thanks to the work being done by Open RAN community. So that's great. And on the core side, besides the infrastructure with OpenStack and Kubernetes, you get great core projects like Magma and OMEC. Magma coming from Facebook Tip and that kind of group, where they try to build connectivity services for less connected areas of the world. And it's really nice. They got a different than standard approach to building a core network, because they focused on best IT practices and doing things the right way in terms of software development. So basically a bunch of software developers created a telco product, which obviously is not compliant with any telco standard compliancy, but it's great and it works. So that's a huge benefit, right? And there is, if you are into compliancy and you need to comply with the government because you are a big telco, you can use another open source project called OMEC, which is providing the same functionality, but is getting after compliancy. So it's not even like that there is a single project for something. You get a huge variety depending on your use case and what you are building. So yeah, I think that's open source on the infrastructure is the winner in telco. Almost all telco infrastructure connecting your calls from country to country and so on is running either on OpenStack or Kubernetes. And in terms of workloads, like the real telco applications, there are already good open source components, but obviously this is still dominated the area dominated by proprietary software. So if you think about important network components like IMS, HLR, or in 5G, the other more modern pieces, they are still mostly proprietary.
Why is that? Why do you think that is? If the infrastructure has gone open source, is the future going to change so those things become more open source as well, or is it?
Yeah, we are seeing it on the radio side already with Open RAN and that kind of initiatives. Right. So even like big companies are jumping on that wagon. If you look at Open RAN, is not only provided by open source communities. You get Intel building a FlexRAN platform on top of their hardware to accommodate Open RAN. NVIDIA is doing the same with Aerial, again a platform for Open RAN, and all of the major players in the silicon space are actually helping to build best Open RAN platforms to run Open RAN type of workloads. And even like traditional big three companies in telco, Nokia, Ericsson, and Huawei, they started having an Open RAN department and started actually creating products which are in line with what Open RAN community is doing. So, and open sourcing their code. So I think that we don't see it yet in the core space as much, but on the radio side, it's happening already. And judging by the success of it and what happened with Rakuten network, for example, with Altiostar, definitely people will start moving into open source software on the core side as well.
It's interesting. We've seen this kind of thing. I say this is a common trend that an open source project comes up, and if it's good and people like it, the big sort of organizations will sort of latch on because it means they can move more quickly, right? They don't need to develop something themselves, and so they can just put their resources into that. So maybe I wonder if you can speak a little bit more and sort of introduce a little bit more deeply and more broadly as to what Open RAN is and the community around that. And I'll see if I can find a link for people who want to go and look around at Open RAN. Can you just tell me a bit more about what it is? You mentioned radio.
Yeah, and so sure. On, so there are several communities which are contributing to the Open RAN space on different levels. And Open RAN basically contains of four main pieces. There is RU, the radio unit, which is a piece of software that actually controls what the antenna is doing. So what is the frequency, what's the modulation, how we do this kind of wave creation, beamforming, and this kind of stuff. We have DU, the distributed unit, and CU. So there are these like three main components of the radio network, and there is a thing called non-real-time RIC. We like our shortcuts in telco, by the way. And RIC is radio intelligent controller. So basically, you get a function that controls the other three and gives them commands and so on. But basically, in the end, it gives you the same functionality exactly as you will get buying a network from Nokia, Ericsson, or Huawei. So that's pretty nice, and it's compatible with the latest standards and actually very good in terms of security, because a lot of people are now fearing about their privacy. There is a big discussion about security versus privacy and these kind of things, and this was like typically a very closed thing. Like earlier in the days of 3G or beginnings of LTE, you had no idea about how the network is working. You put some address in your browser on your phone, and that's it. This like magic happens, and I get connected to the internet, and then I know what happens. So now with Open RAN, everyone can actually inspect it, take a look what's happening, check if the security is really good, proper settings, and so on. So I think that was the main driver why actually people started looking into that area. And the second one is the speed of innovation. So if you look on even the creation of a 5G standard, the big telecommunication companies took like 7 years to create a 5G networks and start advertising them to the market. And the community work, which has much lower number of developers, much lower resources, obviously, like they don't have a huge company backing them up with funding, managed to do it in 2 years. And we have a working 5G networks, which are adhering to standards and on par with the proprietary ones. So that clearly shows you how the innovation is much faster in that approach.
The 5G is a good example, right? How does the move to 5G influence how much open source software is used in these kinds of things?
Well, it gives you an opportunity to actually use it, because if you go to establish telco network and say that, okay, you have your LTE network, we have a better one, which is open source, and but these guys will say you immediately like, hey, we bought already this LTE stuff from this big vendor, we paid them $100 million, and we are not going to change it. It has a warranty for 10 years, it stays there where it stays. But 5G is a new technology, and anyways, you need to introduce new hardware on the sites, new hardware in your data center, and new software to control all of it, right? So this is a nice spot where you can actually make an introduction of new technologies and get some innovation happening, and actually basically lower the cost of operating the network.
Okay, interesting. So it makes things more accessible. It means open source technologies can do these things. And on these Ubuntu on air streams, I don't know if you've watched them before or so on, but we've had some Canonical people on before, and we like to take Canonical hats off and talk about and put our Ubuntu contributor hats on, talk about communities and so on. So I wanted to ask as well, how are you involved in open source telco communities? Are you involved in any of them, or is it just the ones you mentioned already? And how does that work? What are you doing in those communities?
So I'm mainly involved in ETSI OSM. ETSI is the European Telco Standardization Institute, and OSM is open source Mano, and Mano is management and orchestration. Again, we like our shortcuts. But basically, this is a piece of software that allows you to manage and orchestrate and do deployment of telco-specific applications and do day one and day two operations for all telco applications on the radio, on the core side, containerized or virtualized. They are called in telco VNFs and CNFs, obviously, virtual network functions and cloud-native network functions, which are basically based on Kubernetes. So OSM is a really nice project. A lot of people contributing to it, and my role there is I'm leading the VNF onboarding task force, which is basically a group that takes care of introducing many network elements, these network functions, into OSM ecosystem. Because OSM itself is an orchestrator. If you have nothing to orchestrate, you are a very poor orchestrator. So obviously, most of the open source telco projects are working together with OSM and being orchestrated. But what we are also doing, we are approaching vendors who are actually having proprietary network functions if they want to join the community and be able to be orchestrated by OSM, and by that way get into open source world, basically. And what we are doing also is Hackfest. So basically we establish events from time to time, and next one is in September, and you are all invited. On this event, you can, together with our mentors, go through the process of taking a network function, and this particular event in September is about OAI, Open Air Interface, one of the telco open source projects, and we will be helping that community by integrating it with OSM so that OSM can onboard and manage that particular project. So this will be like a competitive thing. So you will be split into teams. You will be able to compete. You can get much more on the link that hopefully Riz will post soon somewhere. But basically, if you are interested in the telco space and want to see how it looks, you don't even need to be like, a telco expert. Don't worry. That's something like with a decent Python skills and a little bit of Linux knowledge, you can have a lot of fun on the Hackfest. So for sure, try to join that one. And if we look at other communities, I'm involved in less official capacity, but I try to contribute as much as possible to different telecom open source projects by doing security research, because I also have my lab here, and I love to tinker with a lot of stuff and test out how the security works on both open source and proprietary network setups. So whenever I figure something out, I do a write-up around that and, inform about the bug and so on. But that's something less of like participating in the community, but rather, making their lives harder by pointing out holes in the system.
Yeah. So there's a lot of acronyms. You've talked a lot about proprietary versus open source software, and it sounds like the kinds of people who would be participating in things like the OSM community would necessarily have a bigger objective. They'd have a bigger sort of agenda. Maybe they're more companies than individuals. But if I was a interested engineer. Maybe I've got some, like you say, Python skills. Maybe I've got some Linux knowledge and so on. How do you get started? Is it events like this? But then once you go ahead and once you've done the Hackfest, beyond that, what's the incentive for you to get going? What's the use case for an individual user if you're not a big telco?
Okay, so first of all, doing that is fun. Like building your own setup is quite easy and gives you a lot of power in terms of if you have like IoT devices or you want to build a smart home system in your place, it's much better than using Wi-Fi or any similar technologies, because into a single 5G base station, you can connect tens of thousands of devices. You don't need like 20 routers around your home if you want to do a proper home automation. So it has technical merits, but also you are learning a lot of skill that is a huge shortage. I mean, companies are hiring like crazy, not only telecom companies, but actually big public clouds, the hardware vendors and so on. They are all getting into telco. Like 5G is a huge topic right now, and combined together with edge and AI and machine learning at the edge, doing the edge inference, for all of those, you need a little bit of telco skills, right? So these are good skills to have for an engineer. And yeah, those would be like the two main topics for an individual to play with, I think.
So, right. So it's fun. You're learning the skills and so on. But so at this Hackfest, what kind of things will folks be doing? What's the objective? What are you hacking?
So the objective there is to take OAI, Open Air Interface, in this particular Hackfest, which is an open source project, and create an automation that allows you to efficiently deploy it, but also do day 1, day 2 operations like upgrades, like scaling out, and this kind of stuff. So basically doing a proper automation for an open source telco project. And actually this project will allow you to have a phone simulator and send a real text message like SMS over the entire system. So we also see how this actually works, what is involved, what are different components on the way, and how your text message magically appears on the other side of the world.
Auto magically appears on the other side of the world. Okay, that's super interesting. And can you put something like this together? Can you build a 5G network on entirely open source software? What would you use?
Yes, you can. So basically, you need a radio piece, and if you want to go simple, there is a project called SRS Run, which is doing the radio part. It's all described in the blog post that you mentioned. We can put a link there as well, but that's like the simplest possible setup. So you get SRS Run for the radio. You get Magma for the EPC, which is basically the core part. EPC is an acronym for Evolved Packet Core, but let's call it a core. And then you get your very simple network. These two components are enough. What you can do in addition to that, either on some local server of yours or on the public cloud, you can put some interesting applications if you want to. And on the next to your telco site, which will basically be Raspberry Pi and Blade RF, but that's like a base station on the top of your building. You can put some applications running and actually using the features of the network. The interesting one you can try is the location. With 5G and location management function, you can get a location with accuracy less than a meter. So it's around 90 centimeters accuracy, and you can detect where your device is. So this is very useful. It's used in many applications in like smart agriculture. There are even in Switzerland, they have cows running with Fitbits, 5G enabled. Like it's not a Fitbit, it's like a special Fitbit variant for cows.
It's a Fitbit. Let's just imagine it's a Fitbit on the wrist. Yeah. Okay.
And cows are running around and it's monitoring their vitals and if everything is, okay with them and where they are.
Cool. And so you can do that kind of thing with your own 5G network and your own open source private 5G network using this blog post and tutorial. That's really cool. Like you say, it sounds like a lot of fun.
Yes.
But what about
sure.
But and like you say, right at the beginning, how much trouble can you get in for something like this for the thing that you're doing now? What about like the spectrum and what about the frequency and so on?
Yeah. So there is a nice comment about 5G enabled cows, but that actually happens and it's real. There are a lot of interesting use cases for that. You asked about getting in trouble. So basically, if you are in US or EU, just start with unlicensed spectrum and do 2.4 gigahertz or 5 gigahertz, and you are safe there because it's like a Wi-Fi frequency for the routers, and you will not be disturbing any like military or police networks and so on. And in other way, just go to a website of your local regulator. You should have a list of frequencies in your country and what they are assigned to. And as I mentioned, in the US, you have CBRS, which is 3 gigahertz something. And this is for citizen broadband access. So any citizen of US can play with that frequency. So you are fine with that as well.
Okay. So look at these frequencies. Where did you say people can look to check these things out? Let me write that in.
It would be your local telecommunication regulator. In every country, they have a different name, but you can Google it probably.
Okay. We don't need to get any links for that then. That's cool. That's interesting. Nice. And so you could do all these things, lots of technologies that are going on. And what's Ubuntu's role in all of this? Where does Ubuntu, not necessarily Canonical, but Canonical contributing to Ubuntu, how does Ubuntu play a role in all of these things? Presumably it's the platform on which a lot of these things sit, but just for the Ubuntu audience here, which we are, can you talk about that?
On the Ubuntu, that's a really interesting thing because the operating system plays a crucial role because most of the workloads, especially closer to the radio, operate on a very high requirements in terms of speed, latency, and memory consumption and usage and so on. So basically with Ubuntu, you get low latency kernel, right? And you can put your workloads on a node configured this way. So for sure, that's quite important. I mean, these are the benefits. Sorry, I got distracted by the comments, but we can answer them later. And
let's answer them later.
The other big role of Ubuntu is the base operating system. So a lot of telecom operators are actually using Ubuntu as their baseline system because of the fact that you get nicely packaged software. Also, a lot of telco-specific projects are packaged as snaps, and that somehow steers people directly to Ubuntu quickly. And also, Ubuntu Core is quite interesting on that front because there are a lot of devices on the edge which require strict confinement, and you can get it there. So there are a lot of benefits of doing that. And anyways, you need to use Linux operating system in order to run most of this. The majority, like 99% of telecom specific software will not run on any other platform. And a lot of them need ARM support and RISC-V support. So definitely like Ubuntu is one of the major platforms and a good choice there, right? And also most of the telecom operators are now looking into expanding their infrastructure towards the public cloud and get some of the workloads being run there. Ubuntu being the most popular system on the public clouds, again, makes your mind like, okay, if I have this system there, maybe the same one on-prem. So these are the main reasons why people are going to Ubuntu. And it's also funny how telcos are moving towards the public clouds because people, like normally you would expect that they will be competitors, right? Because telcos own the edge, they have the base station, they have a compute there, so they would be interested in developers running their software close to the user with low latency on their infrastructure. So why cooperate with the public cloud? And actually, that's really beneficial for the operators because most of the traffic in the telco network is seasonal. So obviously you get much more people calling and sending text messages on New Year's Eve or on Christmas than it's 2 a.m. in the night, right? So your infrastructure has different load levels depending on the time of the year, time of the day, or even if it's Monday or Sunday. So it would make sense if you expect a top peak of some sort of traffic to put some services on the public cloud and use it only for these 2 or 3 days and then shrink it down, right? And you cannot do it on-prem. Well, you can turn off some of the blades, but that's not giving you that kind of benefits, right?
Yeah, right. Okay. Interesting. And we'll get to. There's a couple of questions in the chat, and there's a couple of really big questions in discourse. But before we get into that, just quickly, maybe you said it already, but just quickly reiterate: if someone watching now or watching after the fact, when this isn't live anymore, where would you send them to get started in this kind of thing? If they wanted to learn about Telco, but they also wanted to join a community of people who are interested in this kind of thing and passionate about these things, somewhere they can work together, where would you send them?
So currently, I think that a good place to start would be the Open Run and Magma communities, because they are most active, I would say. There are many people on the Slack channel of Magma, and on the Open Run community, you get a lot of interesting information. And obviously, later on, you should also join OSM community, but that's like an advanced topic in Telco. So before coming there, like there are better places to start if you are completely new to Telco, to start understanding how the networks work. And I would start from the core side, because it's much easier. You don't need even like a radio or special equipment. The core network can be run on your own laptop, so you can just install Magma on your machine and see how it works. So yeah, that would be the easiest way to start, I think. Also, the interesting place, if in your city there is a university or there are some hacker spaces and places where people pay like this, you can join this type of communities and find it. And also, we are actually going to try to enable people, because there is not many tutorials for new starters, and we will be starting a small series in October with tutorials how to get into open source telco and how to build stuff. And if you want to build the lab on your own, I will show you how later on this year.
Later on this year in October. Okay, cool. So Magma, Open RAN communities, join those and see if there's any hackfests around, see if there's any hacker groups, and really get in with those people. That's pretty classic. It's good that there's a couple of well-established there's a couple of well-established communities already. If you have the links handy, like someone said in the chat, send them to me and I'll put them in the chat. Otherwise, if you're watching this after the fact when this isn't live, there'll be links in the description, because I'm assuming Maciej will send it to me at some point, and I'll put them in the description after the fact. If you don't want to find those now, don't worry. We'll send them out afterwards. We'll put them in the discourse post, etc. But if you can find them, we can wait.
Yeah, like we can talk, and I will be looking for them. That's fine.
Okay, cool. So after Yannick talked about 5G enabled cows, he asked if he ran a 5G network on the 2.5 gigahertz band, won't his neighbor hate him when he crashes their Wi-Fi? Is that a thing that can happen? Is that something to be concerned about?
Well, it depends on how cautious you are and what you are doing. So basically, if you live in a house, right, you can put the power of your antenna to a very low setting and just broadcast in, I don't know, 10 or 20 centimeters from your board, right? And then you can put the next board, which will be a modem, and they can connect to each other on your desk, and you will not disturb anything, even your own Wi-Fi. But obviously, if you start, putting 100 milliwatts or a watt of power to the antenna, and you have a big enough antenna, you can disturb your neighbors pretty badly. That's why I said that it's important to, think what you are doing and consulting your local regulations. That's always important. But basically, yes, you can get some interference. You can get even interference for some models of the microwave. So that's something that can happen. And usually it's better to test it in a little bit more secluded environment. Like if you live in a big apartment building in a small flat, I wouldn't try to test it at home. I mean, because you can disturb something on that frequencies. And I would either look for other frequencies or test it out outside.
Cool. Look for the frequencies, test it out outside. That makes sense. And so are you saying that Ubuntu now runs on every 5 gigahertz and 2.4 gigahertz radio? Is that something you can do with Open RAN?
No, so Ubuntu is not running on the radio. So the radio itself is usually like an FPGA type chip, which doesn't have a typical operating system like Linux or something. These are rather like specialized solutions. So the radio itself is a separate thing, but Ubuntu is running on most of the components next to it, which are actually steering that. So the radio control units and this kind of stuff, like components in the telco network which are orchestrating the radio and the antenna itself, then yes. But the radio module itself is usually an FPGA with some embedded VHDL type of software on it.
So it's not on the radio, but it's around the radio and driving things on
Yes.
the radio. And yeah. Okay. The next questions I'm going to go over to Discourse for because there was a couple of interesting questions from the same person. So I'm just going to go ahead and read them out. The first one is, in the traditional bare metal telecommunications network, discrete boxes typically provide a separate network element functions. In the virtualized telco network element functions are virtualized on top of the NFVI. How has this impacted telco network operations, especially when things go wrong? Has troubleshooting suddenly got more complicated, and how are network operators coping? Virtualization provides for tremendous flexibility and scalability, but when things do go wrong, are they much more complicated to troubleshoot? Maybe you can expand on the question a little bit, give a bit more context before you answer the question. But
yeah, sure. I can give a little bit more context because it's actually much worse than the person asking the question thinks, because NFVI and virtual network functions is a thing that was happening like 2 or 3 years it started, like the whole movement. And now we also got CNFs, the containerized network functions. So it's even more funny because if you want to do troubleshooting, you still have some bare metal pieces of hardware sitting in some basement, covered with dust. You have your virtual machines in the process, and you have some containers and some other containers running on AWS. And when you make a call and call fails, in order to trace it, it's not that easy. Yes, that's true. And the earlier approach, like using probes, like physical probes, are obviously not going to help you a lot in that kind of setting. And yes, this is a big issue. However, that's already something that people who created those standards figured out that might be a problem. It was quite apparent that it will not be easy to do that. And therefore, there were a lot of LMA type of stacks created around it, logging, monitoring, and alarming. And they are accelerated with machine learning. So basically, there are already machine learning models which are detecting typical failures and looking at those logs and so on. Because if you try to, by yourself, do a call tracing from a phone in UK to a phone in US, you will typically go through 70 to 100 different network elements, some of them physical, some of them virtualized, some of them containerized. And when the call is happening, they are all involved in that because a lot of things has to happen when you call someone. So first of all, if you put a number in, your phone needs to connect to the tower, right? The radio connection. So it will need to introduce itself. Hey, this is my security key. This is rescalling, right? So there is a lot of stuff happening there. There are separate like authentication and authorization functions. If you are a prepaid user, it needs to check if you have enough money on your account. So it needs to go to a charging and billing system and so on and so on. And then your phone is connecting to your antenna is connecting to the core network. Your core network via other network elements is connected to my core network if I'm in a different country. Then this core network have to actually find me, because if you call me, I'm in Poland, you will be connected to some core data center in Warsaw, but I'm actually not in Warsaw, I'm in Wrocław or next to Wrocław, it's another city. So the network needs to locate my phone. It needs to locate the antenna, which is closest to my phone and has the best signal so that I have a reception. And it needs to tell me that you are actually calling. And what's funny, this is like, as I mentioned, around 70 different network functions. And it all needs to happen in a second or two, because if you call me now, I will see that you are calling in a second. So there is a lot of performance considerations involved as well. And basically monitoring each and every failure manually is not possible, and it will not happen. There are different automation type of tools that are doing that. And that's why we have such a bad user experience actually with telco networks. Like each and every one of us during a whole month had a situation when your call dropped because of some reason, or when you were moving fast on, let's assume the German Autobahn, because there it's okay. If you are driving like 300 kilometers per hour, you got dropped because the one antenna didn't manage to switch you to the second antenna. So yeah, definitely these kind of things will happen. And not all of them are traced. Actually, like if you want to raise an alarm or a red flag and consider something a problem, it must affect more than one user. Like if a single user got dropped, that's not something that will make anyone blink, unfortunately. So yes, this is much harder with that setup, and automation is here to help, but these machine learning models are not perfect and not yet ready to provide like 100% coverage. So that's an unaddressed space, and we as open source communities can do something about it as well.
Open source communities can do something as well. You mentioned logging, monitoring, and something. Is that another open source group, not open source thing that's doing that kind of monitoring for the virtual network functions, or is it a separate technology base that has different communities around it?
Etsy is doing some standardization work and defining how this kind of functions should work. There is no dedicated open source project which is doing monitoring of the entire network. It's rather embedded into different parts of it. So in OpenRun, there is this RIC, Radio Intelligence Controller. It's doing the monitoring and controlling everything. So that's there. In the core network, there will be a different, like in Magma, for example, you will get Magma Orchestrator doing the monitoring. So there are several different places, and typically what people do, they take Grafana, Prometheus, Greylog, this type of open source projects, and direct logs and events there in order to be able to browse the entire history, right?
Right. Okay. Cool. That makes sense. The next question was that traditionally, telco network operators have large, extensively trained in-house engineering departments responsible for daily network operations and other things. How are telco operators coping with the modernization of their engineering departments to handle the demands of the virtualized network? Are vendors occupying more of what was considered the telco operators' network operations space?
Okay, that's another good question and a tricky one because it really depends on the place in the world you are in. So first of all, a lot of big tier 1 operators in Europe and US started hiring people from Amazon, from Google, from Microsoft, and companies like that, like FANG type of people, to actually join the telco and start spreading the knowledge and how to do proper DevOps, what is Docker, what is Kubernetes, how to actually use it, and so on, and train these people. Because like telcos exist for a while, right? A lot of companies are 40 or 50 years old, and there are a lot of people from the legacy network, like even like copper type of fiber and the landlines and this kind of stuff. So obviously there is a lot of retraining involved in that, and not only in the fact that it's now a radio network or now it's 5G, but also in addition, there is another complexity coming with virtualization, with Kubernetes, and this kind of thing. So yes, there are a lot of very big upskill programs where telecom operators are actually training huge amount of people and hiring huge amount of people from the IT space in order to cope with that. In some other places, the popular way to do is to go to a vendor and ask them to manage your network. So you go to a big network equipment provider and say that, hey, give me those antennas, put them all around my country, but you have to manage it, and I will just, get the money from subscribers, basically. So that's nice, but if you have this kind of setup, well, then ask yourself what happens if they ask you for a higher price for maintenance. You have no choice, right? So that goes only for a year, 2, maybe 5, and that is not that great of a deal. So I think that this is another benefit of the open communities and open documentation, mostly and open standards, where people can actually learn it, train, and join the telco space in like finding a job kind of way. So because earlier, if you wanted to learn like 2G or 3G, you basically had to hire yourself to the big 3 and get to know this, because there was not many quality publicly available materials about how the network is working, what are the protocols, how to implement it, and so on. And now it's available for anyone. So I think that the pool of people that are available to join telecom operators and do the real work is much bigger now.
That's great. I love that. And like you were saying before, there's with this upskilling of IT people into telco stuff and telco people into IT type things, with Ubuntu being a sort of base infrastructure or core part of both of those sort of technologies, Ubuntu itself is a good sort of base that covers a good foundation that covers both of the bases in that respect. So it's a good familiar platform to be working on. Interesting. That's really cool. That's the. Oh, there's another question that just comes in. Is the Open RAN network in Japan considered an operational success? Do you know about Rakuten Japan?
Yes.
I probably said that
So
wrong.
basically, Rakuten created their own network completely based on Open RAN. And well, obviously they don't make all their financial results public and so on, but they made their network mainly based on one of the private mobile network like Open RAN vendors called Altiostar. So after some time of running the network, they decided to buy Altiostar with I don't know 100 billion evaluation. So there must be a reason why they are doing that. So I expect that it was quite successful if they decided to buy it and they want to sell it to other operators, right? So I think that Rakuten definitely considers it a success because otherwise they will not put that pile of money to buy the Open RAN vendor that was actually delivering to them.
Are they? So you said they're using a complete Open RAN network. Are they? They're not talking about their profits and so on. Are they doing things in an open way? And is there open documentation on how they're doing things, or is it they're just saying that they're using Open RAN?
The idea behind Open RAN is that what is mandatory to be open is the interfaces and standards. So each and every component now has an open interface, properly defined, and anyone can build any of the components, and you can mix and match different vendors. But obviously, Open RAN is not saying to, I don't know, Nokia that now you have to give everything that you have and contribute it to the community or put it on GitHub. You can build a component which is a part of an Open RAN network, which that component itself is proprietary, and it's done for various reasons. Like obviously, when you have a special Apple component which is handling Apple watches, how they are connecting to the mobile network, they are not going to open source that, right? So there are ways to put proprietary software into Open RAN network. Some vendors do that, some vendors don't. So it really depends. Some vendors even go into a different approach that they have like a platform which is free, but the code is closed source, for example, because I don't know, they are not happy, not yet ready or shy to publish.
They're probably shy. They're probably just really shy about it. Yeah.
But that's a thing that is changing. So I see more and more type of projects being fully open source and available there.
Do you see the value? Would you see value in more organizations, more companies open sourcing these things, or do you think it's or do you think they're at the moment in a very high level broad sort of perspective? Do you think they're getting enough value out of using things like Open RAN, or do you think they would get more value out of open sourcing the whole thing and trying to do what companies like Google do with Kubernetes, and they open source a really large project? Do you think telcos would benefit from that kind of mentality as well?
Well, telcos for sure will, but I'm not sure about network equipment providers who will be actually having to open source everything that they do. So that's not something that I expect to happen soon. But more and more of them, they started putting some components like fully open source, and they see that it's actually a commercial success as well. So I think that it's something that will happen more and more. What's really interesting is that 5G networks are not only telcos. That's a really important thing that I want to also convey to everyone, because if you look at Germany, there was a spectrum auction for 5G, auction for frequencies for companies. And the top companies that were buying frequencies, it was not T-Mobile, Vodafone, or Tele2 or whatever. This was Audi, Osram, BMW, Bosch, the companies which you don't consider like telco operators because they are not. But they need connectivity, and they are building their own networks. Like factories of Daimler, like Mercedes-Benz in Stuttgart, have their own 5G network deployed to handle all the IoT devices. Bosch is doing the same. Siemens is doing the same. Like the best network that I have seen in the industrial space is Osram, also in Germany. They do light bulbs. It's a company that manufactures light bulbs, basically, or LED diodes and this kind of like lightning systems. Mm-hmm. And they are their own telecom operator. And obviously they are not going to big company, big network equipment provider and buy the network from them, because they don't need that use cases. So obviously it's beneficial to get like entire system, but this system contains like charging, billing, lawful or unlawful interception, depending on which country you are in. But that kind of things are not really necessary. You will not be charging or billing your light bulb in the factory, right? So why would I buy a big proprietary bulky system with all of those features if I want to turn the light bulb on and off? So obviously a small open source solution which is directed towards IoT only and eSIM type of devices, not SIM cards, because I haven't seen till now a light bulb with a SIM card slot. This kind of stuff are not that necessary, right? So I would see the explosion of open source based private mobile networks in all the other spaces and not telco, like oil and gas industry, manufacturing, agriculture. There is a lot of stuff happening around smart agriculture and especially around hydroponics. This is a way that instead of putting plants into soil, you put them into water and you can grow them. It's like a closed circuit, so you don't lose the water and you can grow much more plants on the same square feet of land by doing that. And this is all fully automated and controlled by like sensors, actuators, and these kind of things. And usually when people do that, obviously if you have a field, it's a huge area. And this is the place where technologies like 5G shine, because your Wi-Fi router has like 20, or maybe if you buy an expensive 170 meters of range, maybe 100. But if you imagine like a big field, how many routers would you have to put there, and cables and everything? With 5G, you put just one big antenna in the middle of the field and then connect everything to it. So I see the use cases like that actually benefiting most from open source private mobile networks.
Yeah, compared to the actual real big telcos and things. Cool. So we're running out of time. We've got a few minutes left. One of the questions that I had for you that I hadn't written down or anything like this was, you mentioned that you have your little lab that you've got going on there. What are you working on at the moment? What project are you working on now? And what kind of super neat telco-y things have you got going on in your own space, in your own house? What are you working on at the moment from a purely hackery, tinkery kind of perspective?
Yeah, so from a purely tinkery kind of perspective, I'm doing like a smart home, but in the garden. So basically having like fruit trees, like cherries, apples, and so on, to have them controlled with like what is the soil structure, what are the minerals there, what's the level, and when to put water with what composition of additional compounds in order to grow them nicely and so on. So basically it's not only for like fruits and vegetables, but mainly for the flowers, because that makes my wife happy. So
nice.
Yeah, that's a like additional benefit. You can get a good dinner or something in exchange. So
that's what telco's for, right? That's all that telco's all about. Getting a good dinner and making your wife happy. Cool. What are you using to do your pear tree monitoring?
So currently what I'm doing is using the Blade RF as the main board and actually running the network, and everything is running on a set of Intel NUCs. So this is basically like a small mini PC. And yeah, that's like the main pieces of the hardware. Antenna is like a custom stuff that I bought on like Polish version of Radio Shack. The name would be too hard to pronounce, but basically store with antennas. And yeah, that would be it. And most of the IoT devices are controlled either by Raspberry Pis or Arduinos in the field. And these are very like simple type of Arduino extensions, which are doing like temperature sensing or doing pH in the soil and this kind of stuff.
Wow, that's really cool. I've heard about a lot of companies doing agriculture with this kind of thing. There's lots of industrial companies doing lots of different IoT things, and I didn't even think about the network problems that they'd be having. So that's really interesting. I know I've read that blog post that we linked to earlier, and I'll link to it in the description for people who weren't in the chat and so on. But I'm going to be looking at that and taking a look, and I'll probably be asking you plenty of questions, so that's good.
You're welcome to ask questions somewhere on our Discourse as well. If you tag me, I will quickly jump onto it and try to help you if you need to start up with something.
Nice. That's what I was going to say next. So now that we're running out of time, I'm just going to put a link to the Discourse post about this stream in the chat here. So if anyone has any other questions, if they're watching when this isn't live, put them in there, and I'll make sure that Maciej sees them. Yeah. So we're about to run out of time, so I'm gonna say thank you for joining me. I look forward to seeing what you come up with next month, and not next month, what you come up with in October to do even more walkthroughs, this kind of thing. Really introduce people to this kind of technology because it's relatively new, at least in my headspace, but it all sounds really interesting. And I was a bit like you in university when I was looking at these kinds of telecommunications technologies, and it's all sort of gotten away from me. But I really like the idea of automating pear trees. That sounds like a great time.
Perfect.
Yeah. Cool.
Thank you very much
Thank
for
you
an
joining
opportunity.
us. You're welcome. Thank you everyone for watching, both live and otherwise. And we'll see you next week, which will be just before we announce the winners of the Ubuntu 2110 wallpaper competition. And of course, we'll start looking more at 5G cows. It'll be great. All right. Thanks, everyone. And thank you.